Thank you for coming to my talk. Sorry for this slight technical delay. I was surprised that it's very hard to get Wi-Fi very first actually. All right, my name is Ignat. I work for Cloudflare, and today we're going to talk about Linux kernel upgrades. Who here doesn't know about Cloudflare? Raise your hand. Okay, a couple of folks. Catch me later. I usually explain what we do, but probably most people don't need it, so I won't waste my time on this. But yeah, but in a nutshell, we run a huge distributed network, a lot of servers around the world, and they all run Linux, so that's why I'm talking about Linux kernel upgrades, maybe at scale a little bit. So what do? I work on Linux at Cloudflare. I'm passionate about system security and performance, and I really enjoy low-level programming like Linux kernel drivers, bootloaders, and other stuff written in safe programming languages. Since recently, I'm also a Linux kernel maintainer for asymmetric crypto and keys, and I actually have a talk tomorrow at this event about this, and the talk is why I became a maintainer. I was so passionate about the technology, so I decided to pick it up. But that will be tomorrow. Today we're going to talk just about the kernel. Before we start, so just for the show of hands, what do you do in this case? So imagine you're working on your computer, like you do, and you have this, right? So like, oh, updates available. Who will press install now? Couple of hands. Who will delay? Okay. Now, who will press install now if that's not your computer or production server machine? No one. Why? It's like, so yeah, when you manage a fleet of big production servers, like updates are not really well perceived, right? So like you want either not want them or you want to disable them altogether, right? So, and why is that? Like it's basically connected to how we're perceiving the software updates, but also we're perceiving software updates differently. So for regular software updates, we don't like them. We're perceiving them as monsters, but because it kind of like it all works. Like why do I need to risk changing anything? And sometimes it can break my stuff, right? We're just having a talk about like routers, so like people do weird stuff, and then the updates kind of break their stuff, so they don't want them. But yeah, they're kind of like monsters, but they're not like the end of the world. They're a little bit annoying, but not that. But when you talk about Linux kernel upgrades, so it's a different kind of monster, right? So it's kind of like all-destroying universe, and nobody who managed anything in production ever wants Linux kernel. And this is reasonable because, you know, like we as engineers, sysadmins, SRE, we know how to deal with regular software updates. So if your service starts crashing once in a while, once a week, yeah, you can fix it, right? Or you can just tell systemd to restart it, and yeah, your job is fine. Yeah, you'll be running in this kind of like degrade state, but it will give you time to actually diagnose and fix this problem. Well, when the Linux kernel upgrades goes wrong, like you get stuff like this, right? And there is no systemd to say your machine is screwed. If you get a stack trace, it's crashed and doesn't work. No monitoring, nothing. You have to go and somehow reset. So this is why like production folks don't like when their Linux kernel crashes. However, so is the answer not to apply updates? Well, no, because updates are very, very valuable, and if you're not updating your kernel very often, you kind of have some risk of not applying software updates, right? So, the first and most obvious one is like the bugs are not getting fixed, and you say, yeah, like my kernel, it was working fine, I don't have any bugs, why I should update? But here are some real statistics about the Linux kernel which I've collected. So I will be talking about the kernel releases a little bit later in the talk, but just for To give you an idea, in Cloudflare we run like the latest LTS branch, the long-term support branch of the kernel. So we just recently started to migrate to 6.12 kernel, but we either statistics for 6.6 because 6.6 was around more than a year, so it has like more data to show. And basically, Linux kernel patch release, again, I'll be talking about the Linux kernel release process later, releases a patch release every week where it's only bug fixes and security vulnerabilities. So every week you get an update with bug fixes which you might not be applying. And how many bug fixes you are not fixing is actually, these are the number of commits or bug fixes per kernel release every week. And like from the graph you can well see, well, so far it has been 87 bug fix releases for the 6.6 kernel, and 60, like almost 20% of these have more than 100 bug fixes in them, right? 27 is roughly 1/3, have more than 200 bug fixes, and there's like 8 mega releases with more than 500 commits or bug fixes in them. So by not applying a kernel upgrade weekly, you're kind of have at least 100 lingering bugs in your system, right? So which can be triggered at some point. By not applying the kernel upgrade, you're kind of missing on performance improvements as well. So, for example, this is when we in Cloudflare migrated from Linux 5.4 to 5.10. And this is kind of like a graph shows basically the memory footprint of our server. And you can see that when we migrated, so we kind of migrated some servers for evaluation. So we have a test, a control, and a test group. So you can see that the memory usage on the 5 dropped significantly, right? So it's on the single server, and you have like thousands and thousands of those servers. This is like a massive saving across all our infrastructure. So the costs and everything, and by just and we got it for free, right? So we just got it by upgrading. So we roughly saved like 5 gigs of RAM per server, and we got it for free just by upgrading our kernel, because like some nice people from Meta, Facebook, like contributed some memory management improvements at this point. I don't have any graphs yet for our 6.6 to 6.12 upgrades, but because we're still measuring it, but we also get actually better performance by moving to a new kernel. So our servers are able to process more requests per second. It's a little increase, but still, like every little helps. Yeah. Also, by not applying, let's take another view of the problem. So this is literally the same graph of number of commits, but it's like accumulating, right? So what each bar here means the number of commits or bug fixes since the initial release. So they're kind of like 6.3 includes data from 6.1, things like that. And this view gives you a nice opportunity to kind of like perceive a change delta, right? So like if we make a naive assumption that a change, number of changes equal somehow is proportionate to risk, right? So you can like kind of measure risk of updating or not updating on this graph. And there are interesting data points here. So for example, let's say you're now running 6.6.35 and you decide to update your fleet for 6.6.45. So between these two releases, you have 1,454 commits, right? Now let's think like from again, a naive perception, like let's think you have like a very important thing going on, so you decide to keep your systems stable and postpone the update to a better time, right? So you basically, instead of taking 10 patch releases, you like extended 2x, and you will decide to update from 6.635 to 6.655, take 20 releases later. And the change delta between those is 3,605 commits. But if you kind of compare them together, they basically, the difference between the 2.5x. What does it mean? Again, if we make a naive perception that number of commits equals some risk of not applying an update, so you made a 2x delay, not to update your Linux kernel, but you got 2.5 higher risk by not updating the kernel. So sometimes, what I'm trying to show here is that sometimes the risk is not proportional to the delay of not taking the updates. Another big problem if you're not playing, it's not only bugs not getting fixed, your security vulnerabilities are not getting fixed. Yeah, so I actually scraped the new Linux CD announced mailing list, from openwall.net, and basically to get the number of CVEs fixed in particular kernel releases. And I actually, I had this data from elsewhere before, but since beginning of previous year, the Linux kernel project became its own CVE authority, so now the Linux kernel project issues CVE for its own fixed and found vulnerabilities. So this kind of data is firsthand, and what is considered CVE or not. There is a great talk from Greg Hartman. He did it on various events, and it's available online. I highly encourage you to go and look at it, because it might seem a lot of CVEs, but yeah, that is a thing. But from a production perspective, so these are a number of CVEs in each weekly patch release, right? So again, the statistics for 6.6 branch is out of 85 releases the data is available today, 55, almost 2/3 or more, have at least 10 CVEs patched in a single bug fix release. And 17 is 20% more than 50 CVEs patched, right? So, yeah, you might say not all the CVEs are applicable to your system or your workflow, but do you actually have time to review all of them to understand that? Instead, it is just safer to take that update and apply. Because if you don't, not only you're risking your security, you also have a compliance problem if you're running a production service somewhere in a compliance aware requirement. So for example, this is an extract from PCI DSS. If you process some kind of payment stuff, it says that critical or high security patches or updates should be installed within 1 month of release, right? So technically what it means for us is we have to reboot all our network every month, basically, to take all these patches. And it's very hard to explain to an auditor that a Linux kernel is not a critical system because it's the underlying of everything. Who here remembers what happened to ActiveFax? No? Some people do. So yeah, ActiveFax got hacked and a lot of data got exfiltrated. Not because of the Linux kernel, but they run I think an outdated Apache server and they didn't update it. But it still shows a problem, right? So if you don't update your system, people will exploit your vulnerabilities, and it's very hard to recover from that. And given that PCI DSS requirement, which is actually common across many compliance frameworks, so not so fun fact, if you're running an internet-facing Linux system, if your uptime is more than 30 days, you're likely vulnerable to something. Remember those old sysadmin forums in 2000s, and people posted their uptimes of their servers 2 years, 3 years, this is not cool anymore, 30 days is not cool. And by dealing with these constant streams of updates, I saw that, at least in Cloudflare and other companies, people try to apply like common, they say, patterns to manage updates to software, but they are actually anti-patterns for Linux kernel releases. I think like Linux kernel needs to have a dedicated thing, right? So like the first thing is in a like traditional patch management framework says like, oh, if you want, this is very common in finance industry, by the way, like, okay, you want to update the systems, people, you have to go and explain which things from the changelog are applicable to us. Like, you have to justify that date, like, why do you need updating if these changes relevant to us? Well, good luck, right? Good luck scanning every week some 120, 200, or 500 commits and actually identifying if a change is applicable to us. And like, if you ever read the current Linux kernel changelog, it will not say, oh, something on a high-level perspective. It will say like an out-of-band memory access found in like this memory page allocation, and you don't even know like if it's applicable to your workflow. So basically, if you want to apply this framework to justify that, you just need to stamp everything. So why do it in the first place? Just like you have, if there is an update, you have to take it. Because of the volume of the changes there is most likely there is always something which is applicable to your workflow. Well, similarly, this like from security people, oh, is this security vulnerability actually exploitable in our system? Is this code used? Well, it's a reasonable question to ask, right? But I don't think we're asking it from the right person. So this is the ideal entity of an attacker which tries to exploit your system. They're highly motivated to break into your system. It's their bread and butter, so they spend exclusively almost 24/7 to design and implement a successful exploit, right? So this is kind of like this person. Right? But an attacker, like if a particular vulnerability is exploitable in our system, attacker will likely not. But we're not asking this question from an attacker, right? We're asking it on us, like either like the Linux team or security patch review or security person. So there is a different profile. They're highly motivated to go home on time, right? And most likely the Linux kernel is not the only software they need to care about, and they need to review many, many security things going on around the day. And they have other competing priorities, so it's kind of like this person. So does this person can give you a definite answer whether as some, like out of band access in some very deep Linux kernel subsystem exploitable? Probably no. And if you go to many security events, you will notice even like people are successfully chaining several less critical vulnerabilities to build a successful exploit. So it's kind of like exploiting a system is art, and you cannot like make a decision here of 5 or 10 minutes by just looking at the patch description or even the code. Some, like, if you're working operation, they say like, oh, let's kind of like, let's update, but not update everything at once. Let's put it into some canary deployment and let it soak for months to ensure nothing bad happens. But the problem is that the more you soak, right, the more you delay updating your real systems. And again, if you go back to the graph, the more you delay, the higher risk you have by not updating the system. And the same way from a security perspective, by let it soak for 1 month. Why take 1 month? Because when people come to me and say, let's soak it, and say, what's the reasonable time for you to soak it, to be confident? Like 1 month. Like 1 month is too much, right? Because CDs are getting released every week, right? We have a lot of them, and we have 30 days compliance requirements to actually patch all our systems. So soaking in canary once a month just doesn't fit in that agenda. And if you step back, it's like high soaking times probably means like we don't really know what we're looking for. So when I say like, why do we need 1 month? Because, oh, like, what if something goes wrong? Like, let's monitor for the time. What are you concerned about? Is it like I/O? Is it memory? Is it scheduling? Is it something else? So basically, we probably don't really know our workload. So what kernel features or subsystems are important to us? Like maybe for someone it's networking, for someone it's storage, depending on what you run. For database, it's storage. For routers, it's probably networking and something else. Scheduling is for everyone. And it might also indicate that you don't have a sufficient pre-production kernel testing. So actually you can do unit tests with the Linux kernel, integration tests, you can do performance testing, and many other things. One thing I heavily fought in my current company is people just say like, yeah, it's all very great, but just kernel is just too critical. Let's have like more approvals to get it up. And this is what they have in mind, right? Linux kernel is so critical. We need to have more approvals before we release it. Yeah, but what if I told you that I think that kernel deploys are much safer than any other software, especially in production. Agree? Who doesn't agree? And here's the Cloudflare example, right? So in Cloudflare we run, as I said, a huge distributed network. Each dot is one or more data centers in the city, and data centers can have many servers, right? So a lot of stuff. And obviously we don't update it by hand. So how does regular software update work here? Like the high-level view of our software update process. So an engineer writes a code, packages into a Debian package. We use Debian. That package is registered to our package register, and then the servers download the new package, and configuration management system detects that there is a new package and restarts a particular service, right? So it's graceful or non-graceful restart, depending on how engineers design that stuff. But the problem saying that if you coded a bug, the new good or bad state can propagate to production within minutes, because once it's in the register, all the servers download, service restarted. If it's buggy, everything went down. And unfortunately, in Cloudflare, we learned it the hard way. So we had several global outages because of software propagating too fast across our network. Bad software, right? We have like public blog posts around it. You can go and read the details. On the contrary, the biggest feature of the Linux kernel, if you want to update it, you need a reboot. You need to reboot your server. And reboot is not an easy process, right? So we need to drain traffic from the server, put it out of production, so stop receiving new traffic, actually do reboot, and when it reboots, it needs to be reconfigured. Once it's reconfigured by a configuration management system, it runs some acceptance tests that everything is in place and configuration is what needs to be, and after that, only we enable it in production, basically it starts receiving traffic again. We use Bird for that, by the way, thank you. Who maintains Bird. And of course we're not stupid, so we don't reboot all the servers at once. So we have systems in place where basically if I want to upgrade the kernel, I push it to a queue, right, and then a system basically reboots server one by one or in small batches for the new kernel, so we don't lose traffic processing capacity in place, right? So basically, because the way how you deploy the Linux kernel, it's inherently slow-paced and gradual rollout with minimal impact. Did we never release a bug kernel? We did. But as soon as two first servers failed to reboot, we stopped the release and nobody even noticed it. And it's actually, we noticed that even before it hits real production traffic. We have a pre-production dogfooding environment where only Cloudflare employees use the new stuff, so we see it ourselves first. So yeah, the Linux kernel is just safer because it's an inherently slow-paced rollout. You always have time to actually stop the release if it got bad. Okay, clear so far? Agree that Linux kernel is safe to release? So, yeah, the other thing is what I encountered is not all releases, not every kernel release is created equally, because from an outsider's perspective, a Linux kernel release is always that scary thing. But there are like safer and bugs and bugs and security feature releases, and there's like real feature releases, right? So if you ever like work with a Linux kernel, it has like a versioning scheme. So you have this X, like a number, then dot, then two numbers or one number, and another command. So for example, like 6.6.32. It looks like a semantic versioning. Are people familiar with semantic versioning? Yeah? So it doesn't apply here, so it's not, it looks like a semantic versioning, but it's not a semantic versioning system. In fact, the first two numbers are called the major version, 6.6, 6.12, 6.15. So not major, minor as a semantic versioning. And the lastmost number is only bugs and security fixes. So with this last bit, you will never get any new features or major subsystem rewrites, only bug fixes and security features. So it's always quite safe to go from 6.632 to 6.633. But if you go update the merger version, this is where you get new features, where you can get more bugs, right? But how do these get there? So we have the Linux main branch, managed by this fellow. He's the ultimate decider what goes in, but he doesn't develop everything himself, obviously. So he has a group of maintainers developing stuff, and they have their own branches, right? And there are like branches of branches for different subsystems. So for example, drivers, memory management, net, and it's all eventually merged to the Linux branch during a period called so-called merge window. After that, when the kernel is considered stable, so Linux tags a major version, right, which is branched out into a stable branch. So we have a dedicated branch for 6.1, we have a dedicated branch for 6.2 kernel, dedicated branch for 6.3 kernel. And this happens roughly every 9 to 10 weeks. Right? And then when there is a new patch or bug fix release, it's actually tagged on this stable branch. So basically there are now bug fixes accumulated. The Linux kernel tags 6.2.1. But how does actually bug fixes get there, right? So they're not applied directly to stable branches. So if you found a bug in the Linux kernel somewhere, it usually goes through the whole tree, right? So like if you found a bug in some driver, you're not submitting it to the stable branch, you're actually submitting it to a respective maintainer, because you don't only want to fix it in the stable kernel, you want to fix it in the developing kernel as well. So it goes to a maintainer, and then eventually it gets merged to the Linux tree. Once that commit is merged there is a special process which tries to identify commits that are bug fixes or security vulnerabilities. So every stable branch maintainer, it basically cherry picks these commits into the stable branch. And when enough commits accumulated, a new bug fix release is released. So 6.2.3. And this roughly happens every week. So again, every week you get a new kernel which has only bug fixes and security vulnerabilities. Yeah, so as I mentioned, a new stable kernel version is released every 9 to 10 weeks. And even there is a lot of stuff for testing. So the merge window itself, where the chance to get new features in, is only 2 weeks, whereas the remaining 7 weeks are for bug fixing and testing. The leftmost version, this is what confuses some folks, but the leftmost version means nothing. So 4.19 to 4.20 major upgrade can contain more features than 4.20 to 5.8. So like, I think if you basically scan the mailing links, Linus decided to update the leftmost number when he runs out of fingers on his hand and feet. But sometimes it happens when it's 20, when the middle number is 20, sometimes it's 21, I don't know, like maybe he has a variable number of fingers. Yeah, and bugfix and patch releases are released around once a week. So they're denoted by the rightmost version number. They're always cherry-picked from the main Linux branch. There are never new features, therefore regressions are quite rare. In fact, like we've been really aggressively upgrading the kernel in Cloudflare for many years now, and it's kind of like, I remember one or two cases where the regression was actually introduced. It may contain critical security patches, and you almost always want to apply that. So skip all the bureaucratic processes, or because of the sheer number of stuff running and depending on the kernel, there's likely something that is applicable to it. One thing to note about long-term kernel releases, so usually a stable kernel, the one with new features, is active around 2 and 3 months. So a new feature release, right? And after that, it's end of life. And no even back fixes are backported, including critical security vulnerabilities. And it is expected that a new major stable version should be available at this point, and you should just take it. But sometimes it's very costly to, evaluate a new major kernel upgrade for every 2 or 3 months. So there are like long-term releases. These releases where bugs and security fixes are backported for at least 2 years and sometimes more. And it's usually the last stable release of the year. Therefore, these long-term releases released once a year. And this is what actually Cloudflare is tracking to. So once a year, we try to move to a new long-term release. And the nice thing about you don't have to evaluate new kernel that often, but it still provides enough time for a more rigid evaluation of the next long-term release. So that we try to upgrade every year, but we still have a year in backup to properly evaluate, although we try not to evaluate it for a year, of course, so we try to finish it within like months. But yeah, to properly evaluate, because your old kernel is still supported and you get bug fixes and security vulnerabilities. So yeah, and if you're interested more about the kernel, this was actually very well written on the kernel.org website. So, to summarize, what do you need for safe and easy production kernel upgrades? Don't create a dedicated deploy process for the Linux kernel. Kernel upgrades are usually less risky than any other software, no matter how you perceive it. And a simple stage rollout is usually just enough. And again, the kernel, if you're not just rebooting everything at once, which you shouldn't do in the first place, kernel upgrades are naturally slow-paced, and because they require a reboot, and there is a lot of headroom to abort your deploy if things do not work well. Avoid justifying a bug-fix kernel upgrade, right? They should be just taken with no question asked, and actually Greg, the maintainer of all the stable branches, always recommends you to just take all the upgrades because of all these reasons and more. And they contain only bug fixes and security vulnerabilities, and because of the number of them in each release, there's almost likely something that applies to your workflow. Regressions are quite uncommon, and you should definitely think about minimizing canary soak times. Instead, try to move to a metrics observability-driven approach instead, to basically you deploy a kernel in some portion of the fleet and you get an immediate signal if it looks okay or if validating a new feature release is costly, you can stay on the long-term branch. Also, I noticed that if you use like desktop Linux distributions, some of the distributions, like Ubuntu, they like to use a stable kernel and not the long-term kernel for some reason, but then they don't update it, because I recently got a complaint that in the company where people use Ubuntu, they hit a kernel bug, which I personally fixed in upstream, but it wasn't backported because the 6.8 kernel was end of life. And why didn't Ubuntu upgrade to a newer kernel? I don't know. So yeah, you will get at least, so yeah, if you select a Linux distribution, see if it gives you an option to follow long-term kernels instead of like stable kernels, if your distribution doesn't update. So you get at least 2 years of bug fixes and security patches, and but my recommendation is start evaluating the next long-term release early in 1 year when it's available, so you have enough. You will get more features, you get better performance, and you still have like a lot of enough time for safety to evaluate the new kernel and get security features in your own kernel. And you will be accumulating less change delta, which I showed it's risky. And if you don't have already, think about how can you implement improved pre-production testing for major kernel validation. So it requires some investigation. Is actually, for instance, like for our team, so we manage Linux, but if you go to different engineering teams and ask them what is important to them in the Linux kernel, they all say different things because we run a diverse set of workloads, and again, some care about the disk I/O, file systems, networking, and it's basically everything. So trying to understand your workload and basically based on that, write tasks which exercise various kernel subsystems which are applicable to your workload. And it also, having these tasks, it really can help communicating issues to the kernel community because you cannot fix everything yourself, and like whoever tells you they know the Linux kernel is lying to you because nobody knows all the Linux kernel. There are like just too many subsystems and too much code to know. But when you communicate in issues, it's always easier to say, I found the bug and here is a reproducer, self-contained one, which the maintainers can like copy-paste and run and see, if instead saying, oh, I'm having this proprietary service which kind of like does all X, Y, and Z, and I'm hitting this bug, and the maintainers have no way of actually validating the problem. And make metrics-driven decision, not time-based decision. Try to go away from soak times for the Linux kernel to more observability-based decision-making if a release looks successful. Yeah, and actually metrics and monitoring and deploy automation can help with human risk perception. So we talked in the beginning how humans perceive Linux kernel updates as big monsters, and one of the big shifts in Cloudflare were like, when I had to go and ask SREs to update the kernel, people familiar with the process were eager to jump in and do it for you. Like a new engineers who just joined the company or more junior ones, they kind of like tend to go back and like, oh, can I do that? Doesn't it require more approvals or something? So to fix that problem, you just have automation. So I don't ask anyone anymore. I just say, I put a new kernel in the queue and it magically gets updated without people even noticing and understanding that it's an update. Yeah, and it forces you to make data-driven decisions. If a deploy looks good, it provides quick and early signals about any regressions. Yeah, automation encourages regular updates, right? So like you don't have to deal with human perception of the twist. I think that's all I wanted to tell you today. So some conclusions. Again, Linux kernel upgrades are not more risky than any other software. Patch early and patch often, and backfix kernel releases, the ones which the rightmost version bump should be applied with no question asked. And yeah, understanding your workload, metrics, monitoring, and automation will allow your system to stay patch and secure. And not only for the Linux kernel, for anything else. Thank you very much. And I will have time for questions, I guess.
Thank you. Terrific. Do we have any questions? Yes.
I can just shout from here.
Yeah,
Okay.
obviously.
So what is the difference between an upgrade and a live patching, where you don't have to reboot the machine, and wouldn't that be much faster to upgrade often?
So the question was, can't we use live patching instead of like upgrades, which requires a reboot to stay updated faster? So I have researched several live patching solutions, and I kind of go against live patching. And there are several of reasons for that. So people, like live patching is trying to be monetized by some companies which provide commercial Linux distribution as a cool feature. But you have to understand the technical details. You cannot always live patch any vulnerability. So the way how live patching works, you're basically creating a new kernel module which changes all the code, right? And you insert that code into the kernel and replace basically the buggy version with the fixed version. But not all vulnerabilities are control flow based. So for example, you can, like that, you can patch maybe an out-of-band memory access by introducing like a check. But if a patch requires changing a kernel structure, which is not stable across the kernel, your live patching, you cannot easily use live patching for that, because you cannot modify the kernel structure because that structure is expected by the rest of the code in the kernel, right? So for some patches, you still need a reboot. And also developing, if you do it on your own, like it's very hard and tricky to convert a fix to a live patch, and you can crash more systems than you are fixing. So instead, I always say that the ability to continuously and safely reboot your system is a superpower for any infrastructure. And it's not only regarding to the Linux kernel, for everything else. There are many things that require the more complex infrastructure that may require a reboot of some sort. And if you're able to do it safely, it's always easier than if you need to spend time and kind of like orchestrating your. So like once you build the system, once we built this system, when I joined Cloudflare 10 years ago, we didn't have that system. It like unlocked many doors, not only for the Linux kernel. So I would just focus on building against that system, that automation, and it will help you like much better and cheaper than live patch.
So you're essentially saying that if the higher ups in the company don't want to update, we should automate the process so that they don't notice it.
So to repeat the question, I don't know, do we do recording? Yeah. So if some management in the company don't want to update, we should still do it. Just develop automation and for them not make it. Yes, I'm essentially saying that. Because, I mean, you should do what is right, right? I interacted with some folks in like companies involved with, like trading activities, and they all market the fact that they have like the ultimate best fast decision-making process on their systems. And then I learned they run Red Hat from 11 years ago. Like, that cannot work. Like, maybe it works, but maybe if they applied that day, that would be like much richer and better, because they never tried it, right? And it's like, no, we don't care, we just put more hardware. It's like, no, like there is limits to the hardware. You need to have a new kernel to actually utilize it properly.
What do you think about creating incentives for people to take it early, because it can be perceived as risky? So, for example, like bug bounties for companies.
So the question was, what about the incentives of patching early? How, for example, bug bounties. Yeah, bug bounties is quite efficient. We run a bug bounty. I don't know if I think we never got any submissions regarding to the Linux kernel itself, but I mean, we have an incentive, the fact that all our servers are talking to the internet, and if there is like a packet of death vulnerability, it can bring down the whole network, so we try to stay on top of it. Obviously, this is a commercial incentive for like average folks who run their stuff. I kind of similar incentive, and we just saw a great talk about how many threads are on the internet. If you're plugging your stuff to the internet, I think that's incentive to be enough, right? And again, consider what Linux kernel does. The reason there are so many CVEs, and Greg explains it in talk, because they over-assign CVEs, because even what looks like a simple bug, because the way the kernel is the most privileged piece of software you have in the system, it may affect many other stuff, right? So it's always safer to patch it and consider it a security vulnerability than not. So if you're really worried about people not hacking you, you should basically patch it. Because the problem is, when I'm saying every kernel release has patches fixed, it's public information, right? So from an attacker's perspective, I can go and see that, okay, these CVEs and vulnerabilities were patched in 6.632. All I have to do is find servers on the internet which runs a lower version and exploit it. And I know the details. I may develop an exploit, so depending on the hardness of the patch.
Do you use KExec?
The question is, do we use KExec? We only use it for collecting kernel crash dumps when it crashes. We used to use it, but we stopped because it's very iffy technology. It's better to do a full reboot. Actually, it depends on the purpose, right? So the KExec for faster reboots doesn't work, at least for us, because our reboots are slow not because the hardware is rebooting slow. It's because when it reboots, we have to run configuration management. Reboots may take minutes, but configuration management stage may take up to an hour, and then acceptance tests may take more than that, right? So saving pennies on KExec, and we found previous issues with KExec where some UEFI tables were not passed in properly and some other stuff because KExec doesn't, and there is just some hardware expect a full power on cycle to function properly than a KExec. So instead of just fixing all these issues, we moved away from KExec and we use it for kernel crash dumping, which is one of original goals it was designed for. Also, KExec is a security problem on its own, right? There is a nice old blog post how you can bypass secure boot with KExec, which have been fixed, but you need to have a proper kernel config. So there are two system calls, one which accepts a piece of code, which you give to the kernel and it will happily execute it, whatever. You should disable that old version of the system call and the new system call where you have digital sign kernel to execute.
Is your hardware so homogeneous that you don't need to patch the kernel for different machines?
No, our hardware is, we have several generations of servers, so it's not that homogeneous, but there is limited variation, and we try to develop the kernel, good for everything, so it just includes drivers for the hardware that we need, yeah, but we don't tweak kernel according to the hardware. We do have ARM and x86, so obviously there are two variations of kernels for those, but other than that, no.
Yeah, the next is related to the hardware. What if you rely on a fork from a third party, a kernel fork, and you need to provide a security patch, but they are slow? What's your take on that scenario?
So the question was, if you use third-party hardware and you rely on a fork.
The third-party fork.
Third-party fork, if someone forks a kernel specifically for their hardware. Our take for that is actually I can paint. We use vanilla upstream kernel for that particular reason, but also we don't even use distribution kernels from Debian. But what I can paint is to consider when we procure new hardware with a new network card. I really don't want us to consider anything which requires you running out of true kernel driver, because even that is a source of problems. I want hardware which has in-tree supported mainline kernel drivers. Not possible with AI, NVIDIA, still have to do it, but we try to make these exceptions as low as possible. So for example, for networking cards, we kind of got rid of all out of three hardware. We just use upstream technology. So going back to your original questions, it's basically hard. So like, it depends on your capabilities, right? If you, of course, that third-party vendor will not be as willing as to apply these updates, so you have to either take it on yourself if you have the capacity, or reconsider your hardware choices to run on a better supported distribution or something like that.
Have hardware vendors been better at sending stuff back upstream to the kernel? Have they been better at not shipping out of tree code?
For networking cards, I think yes, and we even pushed some vendors to upstream. Well, basically, the vendors that we work with, like, they have, you know, like the mainline kernel and the out-of-tree version kernel, and it's like, oh, if you want this additional feature, it says like, just just move it on, right? And we partly like ask them to do it, but also partly because we try to maintaining an out-of-true kernel modules is a problem on its own, because the Linux kernel doesn't have a stable internal API, right? So once 6.12 comes out, we start evaluating that, and then suddenly all the out-of-tree kernel modules are not compiling because something changed in the headers, right? So we go back to vendors and saying, hey, fix the driver for us and fix it now because we are evaluating now. They're like, no, we'll do it in 3 months. Like, no, like 2 weeks, and like it should work. And they kind of incentivize to put that upstream to kind of like reduce their need to continuously update their code.
Fascinating stuff. Thank you very much. I'm afraid we only have 1 minute left before 12 o'clock. So thanks again.
Thank you.